Hey, welcome to my channel. My name is Jack Jusko. I am a University of Michigan computer science student who's taking a gap year for coronavirus and not wanting to pay a lot of money for online classes this year. I'll be a computer science major next year, and I've worked some programming related gigs in the last year as long as taking classes and doing a work study program from 2019 through 2020. This is the first video in the series, Fundamental Knowledge, where I talk about things that people with interest in the programming world might not know without a formal education. And these are things that I've picked up myself doing freelance projects or exploring online that I think are super useful bits of information to know, and you may not. So, if you're anything like me, anytime you sign in to an online platform, you've forgotten your password, you have 85 billion passwords, none of them work, you have to reset it. So you have to click reset your password, you have to get your email, type it in, send it to the email, and then write a new one. Also, if you're anything like me, this just leads to you forgetting your password a second time when you make a new one and having to reset it the next time that you log in. Now, I'm sure some of you have wondered before going on these websites, why can't they just send me my old password once I hit forget password? I mean, that would make it a lot easier. I could just go and type in my old password and maybe I'd actually remember it instead of setting a new one that I'm going to forget. And the reason that websites can't just send you your old password is because they do not have it. That raises a lot of questions that I'll end up answering one by one. So, A, if they don't have my password, how do they know that when I type in my password to log in, that my password is actually the correct one that I used to create my account? Now that I've got my drawing environment set up here, when you go on a website, say you create an account, you input your password, they're not saving that password. They're doing something called hashing it, and then they're saving the resulting hash. So what is a hash? Hash, put in nerd terms by Wikipedia, is any function that can be used to map data of arbitrary size to fixed size values. So what this means in more layman's terms is that you have a piece of data, say your password, um, you're applying an almost mathematical computation to it to produce a new set of data, say a seemingly random series of letters and numbers that represents your original data, as in, if you take your original data and you apply the same hashing function to it, it will result in the same series of seemingly random data every time. But it is a lossy compression algorithm, almost. So, say I have, here's Jack, my name. Say this is the password that I'm putting into a new website, and I'm applying this hashing function, or the website's applying this hashing function, which is change to it. So what change is going to do here, and this is just a very arbitrary, very crude example of how a hashing function works. The way this hashing function is going to work is it's going to take the last three letters off of my password, move them to the front, and then it's going to add B, B, B. And again, very crude, very arbitrary, but a good example of how a hashing function works. So the way this hashing function is set up is whatever password you give it, pops off the last three letters, adds BBB to the ending. So, say you were to input Jack, you're ending up with ACK BBB. You could also input different things and end up with the same final hash. So this hash is a lossy hash, which means you cannot reconstruct this original data from this. As you can see, the J is missing. The J could be a variety of other things. It also ends up as a fixed size, so regardless of the length of the data that you're inputting there, if your password is 12 digits, or 8 digits, or even 45 digits, you're still ending up with a 6-digit hash. And again, this is a very crude representation of how hashing works. It wouldn't really be completely discounting this J as data. But this is just to give an example so you can see how it works. So they're saving this password. Then say you're going and you're logging in somewhere. Excuse me, log in. You input your password into this web page, and then it goes and it does the same hashing function on it. So you have your password, you hash it, and it turns into this hash. Whatever you input as your password is hashed every time you log in. So then the server goes and pulls whatever saved hash they have. So they saved this hash over here, for example. When you first put in your password on the registry screen, they took your pass, hashed it, got this new input of data, and then saved it in their server. So now in their server, now that you've tried to log in or submitted a login attempt, they will go hash your password and they will pull the hash that they have saved and see if it's the same as this resulting hash. And if it is, then it'll allow you to log in and continue. So why is this done? This is the fundamental question. Why would this be done if it seems almost purposeless? And the point of this is all for security reasons. Say companies, I'm going to reset this drawing board here. Say companies worked like how you would expect. When you register, you take your password, you send it off to this company who stores it in their database, wherever they keep their password information. Then, when you want to log in, you take your password, it is sent to their server, which is, say, this box. The server takes the password they have saved in this database, checks to see if they're the same, and then leaks them out. And if they're the same, it allows you to log in successful. If they're not the same, no login. So this is fundamentally an understandable system. I mean, it makes sense. This would be what my first assumption was if I was just guessing on how login, registration, authentication systems worked. And it was my first guess when I first made an application. And one of my original web apps worked exactly like this until somebody called me out on it and explained this. This is good functionally, but say a hacker manages to gain access to your database here, and they find all the info in here. They can leak out all those passwords to the general public, and then anybody can go and log into anyone's account through the passwords that have been leaked. So say now that I'm a company who's a little smarter and doesn't want this to happen. So I go on register. Somebody types in their password. I produce a hash of it. And then I go and I save it in my company database. When a new user wants to log in, they type in their password, goes to my server, the server does its magic, it hashes it, then it compares the hashes. If the hashes are good, booyah, I'm logged in. Now, say a hacker had managed to gain access to this main security and they found everything that's inside this database. So they have now, all they have is these lists of hashes that represent passwords. Now, this is some info. This isn't info you want to give out freely, but it does do a lot towards stopping a hacker from getting access to accounts, because now that a hacker has these hashes, when they are attempting to log in, they don't have the original password. They have to pass something in here. But even if they pass a hash in through here, when the hash gets hashed, it doesn't end up as the original password. And they don't have the original password because, as we went over earlier, you can't reconstruct the original password from a hash. So the server is forced to hash everything coming in and then compare it to the saved hash. And now all that a hacker has is the hash of your password. So they cannot submit this as a password because then the server will hash the hash and it'll return a new piece of info that doesn't fit with your password's hash, and the login rest will be denied. So that is, in a sense, essentially why companies use password hashing instead of just saving your passwords and comparing them every time you log in. Now, there are a couple of security practices associated with hashing passwords, mostly slow algorithms and salting hashes, which I'm going to explain both of right now. So, slow algorithm seems a bit counterproductive if you know pretty much anything about computer programming, computer algorithms. Um, Programmers are trying to optimize all of their algorithms. They want them to be fast as possible for obvious, common sense reasons. So why would they want password hashing to be particularly slow to happen? And the reason is to prevent again a type of attack against websites called brute forcing. So say you have your website with its login and register system, and somebody is trying to gain unauthorized access to one of the accounts on this. And say it takes 1 second to hash a password that's coming in, and realistically, it would be much faster than this, even with the slower function. But for example's sake, say it takes 1 second. Now there's this outside entity, this hacker, who is trying to gain access to a user account and doesn't know the password, but they have a huge list of passwords that they can try. And they are trying password after password after password, trying to get into this web application. So realistically, if it takes 1 second to hash a password, they can try 10 passwords per second, or they can try 10 passwords in 10 seconds, or 1 password per 1 second here. But say, even though it seems counterproductive on the surface, we want to slow this down. And this second web application takes 3 seconds. Over a series of 10 seconds, if a hacker is trying to gain access to this database, to this web application, with its same login and registry components, they can only try a little bit over 3 passwords every 10 seconds, where here it's 10 passwords every 10 seconds. Now, so this slows down how many passwords. A lot of time people trying this type of attack, brute force attack, have a huge list of passwords that they can use. Having a slower algorithm, even though most things do not use slower algorithms, can slow down how fast an attacker can try passwords. Now, salting hashes is the second primary security measure that computer developers will use to protect their info. So here's 2 terms to know: salt and rainbow table. Okay, so first, rainbow table. Rainbow table is a collection of passwords that some unethical entity has created and what their hash would be, which is they've taken a list of passwords, they've gone and they've hashed all of them, and they've created this list of commonly used passwords and the hash that represents them with a commonly used hashing algorithm. So now, if, as I described earlier, a company's database has been compromised, it's been leaked out, and somebody can get a hand on all the hashes that are in their database, somebody can go through this list, look for hashes that are in this list and in the database's list. If they find ones that are the same, go find the original password, and then they can use that to gain access to someone's account. So what a salt is, and I'm going to clear up some space for you here. A salt is a random piece of information that's added to the end of your password before it's hashed in order to prevent attacks like these. So say my password is Jack. Again, and I register online as Jack. What this website's going to do is it's going to add, say, ABC to the end of my password. It's going to hash it, it's going to save it in a file directory. When I log in again, I'm going to type Jack again. It's going to go through the same process. It's going to send Jack to the server. It's going to change Jack into Jack ABC, and it's going to log in. Since the password is the same, Jack ABC is equal to Jack ABC, the hashes will be the same, and the login will be successful. But here, Jack might be a common password. It might be something commonly used. People commonly use birthdays, they primarily use people's names, etc., something that they'll remember. And hackers can manipulate this, hackers, exploiters, whatever term you prefer, by creating these tables, which we just discussed, of common passwords and their resulting hashes. So say my password is Jack for the 15th time, and some hackers realize that Jack is a common password, and inside their table, they've created the password Jack, and they've created a hash for it, which you can reference if you're using some leaks database of hashes. If my program is using the salting function, where it's adding a little piece of data to the end of my passwords before it's verifying it, and before it's saving and checking these hashes, Jack might be a common password and might have a common hash associated with it in a rainbow table, but Jack ABC is not. And even though my original password is still Jack, and it still should represent this hash, the actual data that's being hashed is different and returns a different hash. So that by itself is a strong security measure. Another part is exploiters, hackers, generally do not have access to what this extra bit of data is that's used on the end of passwords, and that way they can't make these series of common, they cannot create these series of common passwords and hashes because they know there's some data that's on the end of this, but they don't know what it is, and that means the hash is fundamentally different every time. So that concludes the explanation on why companies don't actually have copies of your password, why they can't send it to you, and what a hash is. If you're interested in doing further reading on any of these, I'd recommend just looking up hash on Wikipedia. Hashing by itself, some common hashing algorithms are MD5 algorithm, maybe an SHA-1 or an SHA-2. If you're interested in hashing algorithms that are used for passwords specifically, that are specifically designed to be slower, the most common one, and one that I've actually used in multiple web applications, is called Bcrypt. And I'll link further explanations and some articles about these below. Alright, that's all I've got for today. Thank you for watching. If you enjoyed this video, if you enjoyed content of this sort, be sure to like, subscribe, and hit the bell for notifications. I'll hopefully be making videos regularly and continuing for at least a long time into the future. If you didn't like the content today, if you weren't interested in passwords and how applications online use them, but you have something else you'd like to learn about, you'd like to hear me explain it, be sure to drop a comment down below, and I'll get to it as soon as I can. Alright, thanks, signing off.